So I'm going to go ahead and introduce you to today's presenter, Jeremy Miles. Jeremy is a learning solutions architect with over 30 years of experience in the field of knowledge transfer. His early career as a research biologist gave him the opportunity to develop teaching videos as an alternative to animal dissection. So, Jeremy, I'm going to have a separate conversation with you about that. I'm very interested. He also pioneered the application of streaming video in education before moving into the private sector, where he has assisted a number of web and communications agencies and their clients to capitalize on the use of digital media. He now advises corporations on their learning strategies, integrating competence development, workplace skills assessment, learning infrastructure, and performance management. So with that, Jeremy, I am going to go ahead and turn presenter rights over to you.
Thank you very much, Kayla. And good morning, everyone, and welcome to this session. Over about the next 20 minutes or so, I just want to explain what's meant by augmented reality by giving you some examples of its use in everyday life. I want to talk briefly about how it works, but don't worry, I'm not going to get too technical. And I also want to look at some of the technological developments that are just around the corner and finish by exploring whether augmented reality really offers benefits as an educational technology, or whether it's just another shiny new toy that'll lose its luster before the year's out. So, what do we mean by augmented reality? AR really sits in that space between the real world and the virtual world. Some people call this mixed reality space. That means it takes components of the real world and mixes them to a greater or a lesser extent with computer-generated imagery. I just want to briefly review each of the mixed reality technologies before coming back and concentrating on AR in a bit more detail. So augmented reality takes a live view of the world around us and supplements or augments what we can see with computer-generated data. The applications, they could be as simple as scanning a QR code, or as complex as reviewing video fields from unmanned drones, for example. If we look at augmented virtuality, it's a bit of a mouthful, but that refers to the creation of virtual spaces where real physical objects can be scanned and incorporated into a virtual world. A good example of this is, for example, a news presenter sitting in a virtual studio. Or for you gamers, the set-top camera linked into a gaming console that captures the gestures and movements of the users and allowing them to take control of on-screen avatars or even putting themselves in the screen. And then in virtual reality, the user's placed at the heart of an immersive artificial computer environment. I mean, the user has to really wear some form of VR headset or sit into a simulator to interact with the virtual world. And the big difference in the virtual environment, there's no overlap of the real world. It's completely removed. So, if we go back and look specifically at augmented reality, I want to start just by looking at it in everyday life to give you a sense of how broad the definition is and really to get you thinking about whether you've actually come across examples of it. Probably the simplest form of AR is the use of the QR code. You've probably seen these printed patterns. They're often incorporated into advertising posters or on product labeling itself. And when one of these QR codes is scanned by a mobile device, for example, it can link to a web page that shows extra information about that product. Now, at this level, there's no linking between the object and view and the on-screen information. The QR code simply acts as a trigger to display web information on the phone or tablet, or whatever you're scanning it with. Now, the pattern recognition software is now being developed so that the mobile devices can actually recognize the shape of live objects and use these to trigger information without the need of a QR code. And there are actually applications you could download today, and you sort of pass them around your room, and it will pick up objects. So I'll come back to that in a bit more detail when I talk about how AR works. In television, broadcasters are increasingly using AR technologies to layer additional information onto live video, particularly in sports. If you think about football, cricket, tennis, and even sailing, things like the America's Cup, they now make extensive use of AR, and it's so sophisticated that the extra information that's being layered on top, it's almost subliminal because it blends seamlessly with the TV picture. And more people are now using sat-nav capability of their phones. And what we're beginning to see is the information related to your location popping up on the phone when it's giving you directions. For example, where's the nearest Starbucks? Which stores within 100 meters to me is doing the cheapest offer on an item on my wish list? Now, it won't be long before the image recognition technology can overlay a street map onto live footage on your phone. But again, we'll come back to this in a bit more detail when we look at how AR works. And finally, how you might come across it in everyday life is in your car. Nearly every modern car now has some form of parking assist technology. Now, mostly this consists of dashboard monitors showing the output of a rear-facing camera with reversing zones overlaid. Many car manufacturers are also beginning to experiment with heads-up display, where they actually project dashboard data onto the car windscreen. And although it's not yet at the stage where it can be described as an augmented reality, it shows the potential and it shows the direction that certainly the automotive industry are going. And just as with the navigation apps, when the technology reaches a maturity to overlay computer information on live imagery, it's really going to, I think you're going to see a lot more applications developing. So now an example to an opportunity to use your chat option. Having sort of gone through some of the examples, I just want you to have a think about over the last week whether you've come across or used a form of augmented reality. So if you just use your chat comment feature, we'll see these coming up. I'll crack on, but it would be useful just to see if people recognize augmented reality in what they're doing in their daily lives. So if you have a think about it, add to the chat, and we'll maybe pick some of these up as we go through. So now we've seen some of the everyday uses of AR, let's look at some of the technologies behind the user experience. At the core of any augmented reality system is a suite of components that need to interact in order to integrate this additional computer information with the live environment. And the three main components, the positional components. These include clocks, GPS receivers, compass, and accelerometers, which are all needed to locate the device, the mobile device, in time and space. But interestingly, they're all common features of a typical modern smartphone. And in cars, you might not have all the components integrated into a single device, but you can be sure that they are, if not on in the vehicles, will be appearing soon. You need a fair amount of computing power to register and track live objects and dynamically display the data in real time, and in some cases overlay the two. And the thing to remember is that latest generation smartphones have got processors that are faster than some of the most powerful laptops available just a few years ago. So it really does bring this potential into your hand. And currently, most devices that have an AR capability, such as smartphones and tablets, they need to capture views of the real world by a camera and then display them on a screen. I mean, heads-up displays have been around for a while, mainly in military applications, where the pilot doesn't want to take their eyes off the horizon for a split second. But until recently, those have only just projected instrument data into his field of vision, which isn't true augmented reality. Now, some of you might have heard of Google Glass. This is a pair of spectacles launched by Google a couple of years ago that projected data onto the lens in front of your eye. And now, although Google has gone back to the drawing board with the product, the concept has become well established, and increasing number of manufacturers are now launching similar products. Now, this eliminates the need for both the camera and for a display screen, as the augmented data is projected directly into your line of sight. So now we understand what's needed to generate an augmented reality experience. How does the system work? Don't worry, I'm not going to blind you with technology. This is a very simplified view of the principles at work. And augmented reality is really all about pattern recognition. The system needs a way of recognizing what it can see. And at its simplest level, the QR or barcode is a pattern that contains enough information to tell the system what it's looking at and what to do with that information, such as call up a web address. Increasingly sophisticated pattern recognition algorithms are being developed which can interpret natural 3D shapes. So all you need to do is point your smartphone at a coffee cup, for example, and it'll recognize the shape and trigger what information you want to give the viewer about coffee cups. In AR terms, the point of an object that define its shape and anchor it in space, they're known as fiducial markers. And the processor is constantly scanning, rendering, positioning, and comparing the object with the last known image taken a 30th of a second before. 30 times a second, the scanning is going on. This allows the computer to overlay the augmented data in real time and, importantly, in 3 dimensions, which is how the TV sporting examples we mentioned earlier can look so realistic. Now, the example I've got here, something that we're working at here at GP Strategies, where we're developing enhanced technical documentation with interactive 3D product imagery to generate immersive technical publications on mobile devices. So we use the technical drawing in the document as the fiducial marker that triggers the overlay of a 3D object, in this case an aircraft wheel housing which we'd already built. And it anchors that object in relation to the document itself. And you can control the orientation of the 3D virtual object by getting hold of the paper document and moving that. And the AR software is constantly updating the coordinates from the markers, in this case the diagram, and using the information to change the view of the model accordingly. We've got some neat video of this in action if anyone's interested after this session. So whilst this is a fairly simple example of pattern anchoring, it's the same principle that's used in all instances of augmented reality. And at its most sophisticated level, systems can identify patterns in increasingly transient images as in moving video and provide a synchronized 3D overlay which actually maps to the changing perspective on the video. So, just another pause now. Let's take another reality check and see how many of you might actually have some applications on your mobile device that makes use of one or more of these augmented technologies. It might be a QR code reader, a map application, a stargazer program, or even a morphing tool. So the poll should be coming up now. And let's just take a minute to have a think about that. It would be interesting to see how far the penetration is, certainly with you guys, with this audience, of actually accessing any technologies. So, yeah, just go ahead and answer the question. Do you?
Yeah, and Jeremy, it looks I'm having an issue. The apply button is not working for me for the poll. So I'm going to go ahead and have everyone go ahead and answer that question in the chat field again. That seemed to work well last time. And if I can get this poll up, it's not coming up for me right now. I apologize.
Okay.
If everyone can answer into the chat field, that would be great.
Yeah, we're getting, most people have got astronomy is coming up there, which is a really neat app. So, a lot of people. So what this is showing is that it is a fairly ubiquitous technology, which is great in terms of then thinking about the development of applications. So now we've looked at the principles. I'm conscious of time, so I'm whizzing through this a bit. We looked at the principles and the technology. I just want to look at how we've got to where we are today, and more importantly, what lies ahead for AR, particularly in relation to learning and development. So this is just a very brief overview of some of the key milestones in the development of augmented reality technologies. And early applications were developed for mainly military and meteorological services. And really you can see the timeline starts bunching up around the explosion of the web around 2000. And whilst virtual reality became the domain of the game designers, augmented reality has developed at a steadier but more consistent growth amongst retail and the infotainment services. And over the past 18 months or so, mainstream players like Google, Microsoft, Epson have all been making significant investments in the technology, which again illustrates that that we are looking at a more maturing technology. So what I've got up here is just a list of some of the applications that, where AR is already in use. And I don't want to go through all of these, but I really just wanted to highlight the breadth of areas where AR is being developed, from construction. So, for example, in the earthquake in New Zealand a couple of years ago, the University of Canterbury released an augmented reality application and allowed city planners to visualize the buildings that were destroyed. It's also being used a lot in archaeology. I mean, some of the disastrous destruction of antiquities that's going on at the moment, it is really one of the only opportunities of trying to preserve what's there, all the way through to things like emergency management, search and rescue. Industrial design is a huge area where AR is really helping the designers, both before a product is developed and also once it has been, to compare the digital mock-ups with physical mock-ups to look for the discrepancies between the two. Medical is a huge area as well. So, just to give you a sense of where AR is heading, literally this is just a snapshot I took last week of scanning the press and looking for some of the headlines. Now, what it shows is a maturing industry. The automotive industry is often a pioneering sector, and the app just launched by Hyundai is a really good example of where AR provides a perfect alternative, in this case, to the instruction manual. And literally, you point your smartphone at any part of the car, inside or out, and you can get an animated guide of what needs to be serviced, from how to change the oil through to what the flashing warning light on the dashboard means. And this is now being sold as a commercial application. I mean, many companies are investing seriously in heads-up technologies, indicating that the concept has true potential. And these include the entertainment giants, such as 21st Century Fox, as well as manufacturers of functional products, such as motorcycle helmets and construction hard hats. And looking even further into the future, the interest in microtechnology incorporated into contact lenses is really gaining momentum. And whilst this still might be stuff of science fiction movies from where we are at the moment, you just think of the pace of miniaturization and technological change. It really can't be ruled out as a future development. Now, obviously, augmented realities are not appropriate in all aspects of learning or development. So I just wanted to look at some of the areas that will be particularly suited, and really where might be some of the key limitations. So some key applications are really around where physical or spatial orientation is important. It could be anything from stargazing. A lot of you said you've already have those apps, to art appreciation. A lot of museums are allowing visitors to download the app beforehand and get far more detail about paintings in front of them, through to human anatomy. More apps are overlaying 3D models of what's inside you on top of the live body. Step-by-step instructional information is a definite candidate for enhancement, which really is already beginning to make the printed instruction manual a thing of the past, as the Hyundai announcement is beginning to allude to. Inspection, servicing procedures, when you think carried out by operators in the field, can really be enhanced, particularly if you're thinking of heads-up displays, which are now being incorporated into hard hats, and things like in logistics. Warehouse operators can visualize stock and order details from their ERP systems actually on the shop floor and position that in terms of the physical stock. And I mean, it's all about data visualization, and just think about the next big thing in the internet, which is the Internet of Things, where more and more products from fridges to cars are being connected to the internet. You can really imagine how AR can provide a visual interface to that. So what are some of the current limitations? Well, it relates both to the display interfaces of data. I mean, the smartphone is still the most common delivery platform, and yet it's got a limited screen size and, by and large, requires 2 hands to operate, which is a limitation of use in the workplace. And commercial GPS is still not able to pinpoint position to really within anything but a few meters of accuracy. There are other technologies like beacon technology that can produce greater accuracy, but it is still, it can't get you down to that pinpoint location. I mean, the more information presented on the screen, particularly in a work environment, potentially causing distractions, and you think of that when driving or operating vehicles, can be dangerous, if not fatal. And finally, as feature recognition systems become more accurate, then the whole field of data privacy become more relevant, something we really need to be thinking about. So I think my time is up, and really just a few key takeaways in summary from this. Just think, I mean, as I said, your mobile device is already AR capable. And if you look at the number of downloadable AR apps, they are increasing by the day. So I'd recommend go out and just try some of them. If you want to start getting into the development, then the QR code is really the easiest starting point. It's very easy to print out a QR code, and even though it might not be particularly immersive, it starts bringing that additional information at the point of need. There are a number of software companies now developing toolkits there are free versions of those, and the license fees are pretty small. So it's now getting to the stage where if you do have the aptitude and the interest of actually, especially if you've got some resources like 3D files anyway, of building AR applications. And the bottom one really is from an educational perspective. You need to think differently. You need to think visually. It's a visual medium. You need to start thinking about how we can bring the learning environment into the live environment, because AR really does break down those barriers. But that really takes a different paradigm in terms of learning design. So you need to just have those AR hat on when you're thinking about learning design. So I don't know, Kayla, how we're doing on time. If we've got time for any questions, I would be happy to answer them. So thank you for your time, and back over to you.
Thanks, Jeremy. That was a great presentation. I know these 20-minute sessions can be hard to try to get all the information in, and we did go a few minutes over, but we are going to stay on for Q&A. I hope that those of you who are able to stay on the line can still join us to get some questions answered. Just as a reminder, if you do have a question, be sure to enter it into the Q&A module at this time. We covered a lot, and there is still more information to discuss, so we also encourage you to continue the conversation with Jeremy beyond today's session. His contact information will be available with the slide deck. We'll also be sending everybody a link to a follow-up blog post where he'll be addressing some of today's key takeaways, as well as any of the questions that are answered or asked today if we can't answer them in detail. I'd also like to remind everyone that the recording will also be sent to the email address that you provided. So we do have a few questions coming in. I want to get to this first one right away. How cost-effective is augmented reality as a learning technology?
Good question, and I think one of the key elements with any adoption of any technology is the availability. And one of the things I wanted to stress with this is we all have the platforms that can access AR in our pockets. The smartphone, the tablet has all the tools, all the components that are needed. And even if it is at the simplest level of just beginning to experiment with bringing in additional information into a live environment. As I say, the QR code, it's a simple approach, but we find, especially with people that have a lot of resources around but just don't know the best way of giving access to them, is to actually incorporate the QR code into basic handouts and just trigger websites or trigger assets. And that just starts getting you thinking about breaking down these barriers. As I say, there are a number of development kits which are very cost effective. So I think it's more about the imagination. With bring your own devices, the actual hardware isn't an issue. So I think just look at what's out there, download apps, try them out, but think from a learning development perspective, and you can certainly start dipping your toe in the water with very little outlay.
Great. Another question came in asking if you could provide some more additional specific examples of how augmented reality is used in learning and performance support.
Yeah, I mean, as I say, it's depending on the sectors, but certainly in biology, then, well, in our area, we do a lot of support around technical documentation, and we have so we've started integrating the technical manual and actually using the diagrams themselves as the triggers. But a big area that's generating a lot of interest is in the teaching of biology and anatomy. Some of the applications that are now around that can recognize natural shapes, that could even be a human body, and where you've got a whole set of 3D models. A good one that's being used at the moment, a 3D model of a rib cage, and what that's doing is then you point your smartphone at your colleague standing opposite you, and you immediately get the rib cage projected on top of that. And because, as I was talking about, these markers that anchor that, as the person turns around, so you can see the rib cage turning around. So it's really where there are physical objects that you want to interpret in space and time. If you've got those assets, those 3D assets, which you can now buy off the shelf, or in educational terms, increasingly you are getting 3D libraries and repositories out there, and use tools. There are a lot of software tools that can do that anchoring, and you can really start getting some very effective use out of it. And another one, as a lot of people seem to be having the stargazing now, just think about bringing astronomy into physical geography teaching, because then you can just bring not only the night sky to life, but there's a brilliant application that's out there at the moment where you get the whole solar system spinning around in front of you, and you can compare sizes and velocities and relative masses. So the more physical object-oriented the topic, the easier it is to think of AR applications.
Great. We've got about 3 or 4 more that came in, but due to time, I'm going to ask you one more. And then if we did not address your question live on the call, I apologize, but we'll make sure that Jeremy follows up by answering it in the blog post that will be emailed to you probably on Monday. So this last question, how are organizations balancing this technology on the work floor to make sure that employees aren't spending too much time on personal social media versus the actual learning?
Right. Again, a really good question, and I think a lot of it has got to do with the devices themselves. I mentioned one of the potential limitations is if it's a handheld device, then it's not, you're using your hands on that, so you can't really be doing your job. There is one of the mainstream safety wear providers of hard hats and safety glasses has just released a hard hat that has the ability to, it's sort of the next generation of Google Glass. So it's not here mainstream yet, but if you can have that hands-free heads-up display in the workplace, then it becomes a tool that you can't actually really use for, it's not designed for surfing the web. It's designed to overlay specific information on what you're doing. So I think that will be less of an issue as the wearable technologies really take hold and become a common part of the workplace.
All right, well, I'm going to go ahead and wrap things up due to time. I want to say thank you again to today's speaker, Jeremy Miles, and thanks again to everybody who attended for your time and attention. We hope that you'll join us for our next session, our next Learning Trends webinar on using beacon technology to contextualize mobile learning. This will be on January 28th. This is next week. For GP Strategies, I am Kayla Ross, and I wish everyone a great day.